Once again, good morning. So today we would be at the end of unit number 6. This is probably the last topic of the unit number 6, that is voltage to current converter and current to voltage converters. These are two topics are left. And if you have to see the previously what we have learned in the unit number 6, so it is based on the converter circuits. And in this converter circuits, we have learned the digital to analog and analog to digital converters, as well as we have learned the phase lock looped voltage control oscillators, phase detectors, uh, this kind of circuitry. Now we have to be learn voltage to current converter. So it is very simple and very well understood with the title. So here we have to be see that uh, an ideal voltage control current source is one of that is supplies first a current I naught that equals a fixed constant K times the value of independent controlling voltage Vi, or in other words you can say I naught is equal to K times input voltage. Means voltage to current converter is what? Your output current is proportional to the or depending upon the input voltage. And the second feature of this is a current which is independent of the load that it drives. So you can see in the equation that current is solely depend upon the voltage, input voltage, and a proportional constant. So it is independent of the load what you have connected. Okay. For uh, converting a voltage signal to a proportional voltage current, there are two converting circuits, namely first voltage to current converter with floating load, and second one is voltage to current converter with grounded load. These are the two different configurations for this topic that we have to learn today. But in both of them, voltage to current converter accepts an input voltage Vi and gives an output current IL, that is the load current. Okay. Now you have to see the first configuration, that is voltage to current converter with floating load. So you can see the diagram, and please note it down this diagram as well. So you have to be found that here there is no separate load resistor is connected. Even feedback resistor is given as a name of the load resistor. Okay. So here feedback resistor would be play the role of the load resistor here, and there is no separate load is that is connected through the ground and output terminal. That's why it is a floating. There is no ground uh, signal is connected to the load resistor. And if you have to see, input voltage is applied to the non-inverting terminal. Okay. And here in the inverting terminal, there is a one more resistance R1 is connected between the node A and ground. So if you have to see, this is the floating load voltage to current converter, and voltage at node A, it is Vi. So if you have to see, uh, as we know that there is no current would be enter into the op amp, so IB is equal to 0, bias current is here 0, and if it is 0, whatever the current that is flowing into the load resistor, that is IL here, would be also flow through the R1, because no current is enter here. So I is 0 in this particular branch. So whatever the current reach to this node A, that all current would be flow through the R1 as well. So here IB is equal to 0. So Vi is equal to what? IL R1. Okay. Now from this we can also derive IL is what? IL is Vi upon R1. So This is, you can consider equation number 1. So here the input current is converted into an output current IL. Since the current flows the signal source and load, signal source provides this load current. In this way, we have seen that from voltage to current converter, your output current is depending upon the input voltage. So it is proportional to the input voltage. That's why it is called the voltage to current converter. Same circuitry we can implement with the help of uh, grounded load. So you can see here what is the grounded load here. So the next circuitry is voltage to current converter with grounded load. So this is the circuitry that would be give the information regarding the voltage to current converter with grounded load. Here you can see that uh, non-inverting terminal through which we have connected the VI, and inverting terminal is as same as in the previous circuitry. Only the feedback resistor is same as the R1, RR. And here in the non-inverting terminal, there is another feedback resistor RF, and through this terminal, you can say it is a terminal which is having the voltage VA, because both are same. There is a load resistor RL is connected. Now the load resistor is connected between this terminal as and ground. That's why it is called a grounded load. Okay, this is more stable circuit than the previous one. Now, if you have to be analyze this circuitry for the grounded load circuitry, so you would be found that here the voltage at node A is VA, and due to virtual ground concept, the voltage at this node would be also a VA. Okay, and as we know that IB is 0 always, because there is no current would be enter in this particular op-amp. So whatever the current that is flowing through the VI, that is I1, this would be flow on this branch only. This is I1. There would be a 0 current in this particular branch. So what happens at this node, two currents would be join this node, I1 and I2. So in this way, I1 plus I2 would be equal to IL. Okay. And here we have assumed that this R1 RF, R1 equal to RF is equal to R, same resistor. So after this assumption, what would be happen? You can see here I1 plus I2 is equal to IL. So here I1 is what? It is VI minus VA upon R. You can see here once again, what is I1? I1 is VI minus VA upon R1, and here R1 is R. Similarly, what is I2? It is V0 minus VA upon RF, means V0 minus V upon R. So it would be equivalent to this, that is mentioned here, Vi minus V upon R, V0 minus V upon R is equal to IL. So Vi plus V0 minus 2VA is equal to IL R. So what is VA is here? VA is Vi plus V0 minus IL R upon 2. So this is your equation number 1, and here you can say equation number 2. Okay. Now, as we know that input voltage is connected to the non-inverting terminal, that means it is a non-inverting configuration, and we know that for the non-inverting configuration, the gain formula is V0 is equal to 1 plus RF upon R1 into Vi. So V0 upon V naught is equal to, what is the RF here and R1? That is R. 1 upon R into Vi means 2 Vi. And what is Vi here? 2 Va. The terminal voltage Va. So same it is mentioned here. So V naught is equal to 2 times of Va. If V naught is equal to 2 times of Va, so here from the equation number 2, if I have to say from equation number 2, 2 times of Vi is equal to Vi plus V naught minus ILR. So V naught would be cancelled out. So here remaining terms are Vi is equal to ILR. So finally the load current is equal to Vi upon R, means it is proportional to the input voltage. In this way we have seen that in the voltage to current converter, either you are using a floating load or grounded load. In both case your output current is proportional to the input voltage. Okay, so this is the uh, one of the converter that we have learned today. The second one is, that is current to voltage converter, or that is also called current control voltage source. So it is I to V converter. So there is again two configuration, inverting, another is non-inverting. So first configuration is, please note down the diagram. This is inverting current to voltage converter. So a current to voltage converter, or an ideal current controlled voltage source, also called as trans resistance amplifier. And in this trans resistance amplifier, there is two features. First one, the output voltage is equal to a constant K times magnitude of input current I, or you can say V naught is equal to K I. Means output voltage is proportional to the input current, just opposite to the previous case, in the case of V2I converter, where IL is proportional to Vi. Now here V naught is proportional to I. And second is, uh, output voltage is independent of the load connected to it. The constant K has in terms of unit of ohms. So you can see here, this is the circuitry that represent the current to voltage converter, inverting current to voltage converter here, because in the inverting terminal we have connected the current source, and parallel to that is the R1 resistor. It is a Norton equivalent circuitry, and this is the terminal voltage VA, and this is a non-inverter connected to the ground. This is the optional part. CF is optional. I would told you that why we have to use the CF. If you have not connected, it doesn't change any conditions. It is only for the high frequency circuits. Then RF is a feedback resistor, and there is output is this. So if you have to be see here, in this particular condition, in the circuitry, the constant current voltage source, it is generally easier to measure voltages here. For example, an output current proportional to an incident light energy. Some light energy is incident is obtained, some photo devices here, and because it is what you would use for generating the current. For voltage, we have use the function generator, but for current, you have to use some sensors or transducers. So here we have suppose using a case we have taken as an example, where an light energy incident on the photo device, which maybe photo device. What is a photo device? You can consider it is a photo cell or a photodiode. So this photodiode would be convert this received light energy into the corresponding current. So the output current from the photo device can be converted to the voltage by using this current to voltage converter, that is shown in this particular diagram 6.23. So I hope till you have draw this diagram. So we will be further analyze this circuitry. So here you can see, due to the virtual ground concept, here VB is equal to 0. So VA is also equal to 0 due to the virtual ground concept. So the current through the R1, if VA is 0, so current through R1 is 0. No current is flowing through this. Only this current would be flow through this network II, and this current would be not entered to the op amp because we know that IB is equal to 0. So this whole current would be flow through RF. That's why it is the current is II here. So here you can say VA is what? This VA is here, or you can say V naught actually. V naught is here what? I minus II into RF. II into RF. And it is inverting terminal, so minus II RF. So this is mentioned here. So here V naught is equal to, sorry, it is V naught minus II RF. So in order to reduce the high frequency and possible oscillations, you can connect CF parallel to the RF. It is not necessary for low frequency signals, but where you are using operate the circuitry in the high frequency or some oscillation networks, so you have to use the CF in parallel to RF. Okay. Now we have to see the another configuration for this, that is non-inverting configuration. So if you have to see the non-inverting configuration, that is mentioned in this particular slide. Here now in the non-inverting terminal, we have connected the current source, or means the output of the transducer of photodiode. So it would be produce a current II that is flowing here, and the one resistor parallel to this is Ri is here. Inverting terminal is connected to the R1, that is the grounded, and the feedback is connected to the inverting terminal. So what happens? The input current II has a return path to the ground. Okay, we have return path to the ground. The voltage at the non-inverting input is Vi is equal to what? It is, because IB is 0, so this current would be what happens? This would be flow to this path. So Vi is equal to what? I into Ri. This is your Vi. Okay. So the output voltage would be, as it is a non-inverting configuration, so it is 1 plus Rf upon R1 into Vi. And what is Vi? Vi is 1 plus Rf upon R1 into II into Ri. Okay. So in this way, if you have to be see, this equation would be, for this configuration is equation 1. So output voltage is proportional to the input current. So it is called the current to voltage term. If you have to know the value of input current, you can find out the output voltage. So these are the two simple configurations that we have seen. In the first case, voltage to current converter where the floating load and the grounded load, and the second one, current to voltage converter where the inverting configuration and the non-inverting configuration. And remember that to produce the input current, you can use what can I say, transducers to produce the current, input current. Okay. So this is all about the V2I and I2V converters, and this is also all about the unit number 6. So these are the some reference books you can refer for learning this topic of converters. So that is a very good book, Ramakant Gaikwad, for all op amp chapters, unit number 4, 5, and 6. This book is very good, very simple, and good book is there, op amp and linear integrated circuit. And other is also very good book, Salivahan and Kanchana. It is also good book. But generally, in most of the colleges use this Ramakant Gaikwad. It is Indian writer also, and very good written text book is there, and it is also used for the your GATE examination as well as the another examination. So if you would be going to purchase this book. And for this book, I have also the soft copies available. You can If you would be demand, I would be share you the soft copy as well. Okay, now another resources that you can use to learn the uh, analog unit number 4, 5, and 6. For this, I would be refer analog electronics circuits. So that is course by the NPTEL, okay, or analog circuits. There is a video lectures are available there where you can use this resource. Okay, so this is all about from my side for unit number 6. I would be post you the assignment, last assignment number 6 today on your Google Classroom, and please complete your assignments till I have also shared you the 6 practicals write-ups. Please solve all the questions and complete write-up. Remaining 6 write-ups I would be share within 1 or 2 days. I am finalizing this, means there is only the formatting is remaining. So I would be complete after completion of this formatting. I would be share the rest of the practicals within 1 or 2 days.
Sir, we have to write those practicals.
Anyone has any question? Yeah.
We have to write those practicals or not?
No, you have to be. What happens from the past 2 years? Our college has removed this problem of writing the write-up. This is a well formatted write-up. You can have to be take the printouts, and only you have to be write the conclusions and whatever the questions asked at the end of the practical, that you have to be write on the separate uh, pages. Either you have to use a two-side page or one-side page. Generally, the practical write-up pages we have to use. Okay, so A4 size page are there. Do not use a general notebook. Okay, and that pages you have to be attached along with the every practical at the end of this, with writing properly the question numbers and answers, as well as you have to also write the observation tables and the results. Generally, for the electronic circuits, in every practical, uh, whatever having in the simulation, you have to be attach the printout of the circuitry and the waveform, and whatever having the hardware, you have to be take the readings. Okay, but due to the COVID-19 situation, we have not able to take the physically the practicals. That's why I have every practical I've taken in the simulation background. So you have to be preserve the diagram with you, and we would be see as per the instruction of the college. I would be brief you what you have to be do, but at now you have to be complete the questions and take the printout of the write-ups. Okay, any other question?
And sir, when we have to submit that?
The date would be declared to you. That is actually still not declared from the higher authority. Maybe next 1 week, this week, we would be finalize this, and after finalizing, I would be convey you, or the other teachers would be also convey you, or maybe your class teacher. Okay.
Yeah.
Anything else you want to ask regarding the subject or anything? And those who have missed the lecture, you can refer the YouTube channel from the past 1 month. I am not sharing the video link because I think all of you are familiar with the channel. You have to visit my YouTube channel and go through to learn the visit and see the lectures. Or even I would be send you the handouts also of all uh, units that I have taken through these slides. Okay. Anything else you want from my side, you can ask me.
सर
Yes.
हा सर पीपीटी जर सेंड केला तर चालते सर आम्हाला पीपीटी सेंड करा ना हँड रायटिंग नोट्स पेक्षा.
Okay. Take it. Anyone? Okay, I would be sharing the PPTs. Anyone else? Okay. So this is from your side. Okay. Please go through the preparation of all these topics, because what happens, whatever the subject you are learning in the second year, that is the fundamental of this branch, and these all subjects would be building blocks of your career. And if anyone who want to go into the core sector of electronics engineering, or interested to give the GATE examination, go for the higher education for IITs, NITs, or even the foreign universities for the same course, for MTech or PhD, or maybe you have to be want to do job in the PSUs or government sectors based on the your branch. So this second year subject would be asked in the competitive examination, like the GATE. GATE is a one of the, you can say, door to open you for the government jobs as well as the PSUs or higher educations in the IITs and NITs. So for that they ask they have asking questions from the 8 subjects of the electronics engineering. Out of that, maximum subject is from the second year. Okay, like this electronic circuits. Now Pune University has been be merged 2 subjects actually, electronic devices and circuits and a linear integrated circuit in one subject. So this is having a very high impact on the GATE examination. So uh, go through thoroughly from this topic, and do not go for the shortcuts. Try to read the books and explore the circuitry. Try to learn how to draw the circuitry, make yourself familiar, not only for the examination purpose, but for the long term learning of this uh, branch. Okay, and there is a huge scope on our branch nowadays and in future as well, because even in the software industries, uh, people are not demanding a person who is comfortable and a good knowledge of software as well as the hardware. Only knowledge of software is not enough to survive in the industry. You have to be also know the knowledge of hardware. Either you have to be see the service sectors, either it is TCS, Infosys, Capgemini, or anything. For the long term, they are now demanding the student who are familiar with the hardware design also of the system, electronic systems and others. So you have to be a master of your subject, electronic subjects, as well as you have to be know the knowledge of the data structure, C++, like these languages as well. So both is required. Only consider one part, it would be not enough to get the jobs, and not only getting the job, but after that survive on the sector. So both kind of the knowledge is required. So do not leave anyone. Software is also important as well as the hardware part. And this is the subject that is deals with the hardware maximum. So you have to be having the knowledge of both the terms. Okay. And best of luck for your preparation of the prelim and other upcoming examinations, maybe oral, practical, whatever. It is not still informed by the university what is the pattern and how they would be conduct the examination, but we are hoping that theory may be in online pattern maybe, but we are not confirmed still, because there is no information from the university. And maybe for the practical examination it could be uh, physically, when the colleges would be open, most probably on the January first week. It would be, you have to be got the chance to come into the colleges. And it is my only observation. It is, I'm not saying it is a university decision or college decision. Maybe you have to be conduct the practicals physically, and then after 1 or 2 weeks there is a practical examination would be there. So complete your write-ups before, as before, and then at that time only you have to be write only the readings. Okay, and ready for the examination. Okay. So please start to fill up your attendance. I hope all the best for the future you. And any problem, any help you have to be required, immediately message me on the WhatsApp or call me, or ask for any help you want to. I am always ready for you. Okay. Thank you all of you for attending lecture today. Thanks a lot.